Hello everyone and welcome to Get Smart with Stanford. In today's grade 12 mathematics lesson, we will be working through a full exam style question paper, and this combines calculus and quadratic functions. In here we are given a function and the gradient of a tangent at a specific point. From this information, we'll need to find the values of the constants, to calculate the x-intercepts, to determine the turning points, to sketch the graph of the function, and finally solve the inequality using the graph. This is a very important type of a question that often appears in final exams. So just make sure that you follow each step carefully and understand what exactly we are going to deal with. Here we are given a function. There is the function f of x equals minus ax squared plus bx plus 6. So we've got a lot of unknowns here. We've got a, which we don't know as yet. We've got x, which we don't know yet. And we also have b, which we also don't know. So we need to calculate and find out those variables. I'm definitely sure we're going to need that. But yeah, 4.1, they say the gradient of the graph, they say the gradient of the tangent of the graph of f at the point where minus 1 and where minus 1 is the x value and 7/2 is the y value, that particular gradient is 3. So now we need to show that a equals half and b equals minus 2. In other words, prove that a equals half and b equals 2. How are we going to do this? Because we've got a lot of unknowns. So how are we going to do this? But now we've been given the gradient of the tangent. So let us look at it now. Okay. What have we got? F of x equals minus a x squared plus bx plus 6. When we have this, what can we do? We've been given the gradient of the tangent and the derivative of this function. The derivative will give us the gradient of the tangent. Right? So if the derivative is going to give us that, now let us go on and find the derivative by differentiating. We have learned this in grade 11, I believe, so we should know by now what it means to differentiate. So when we differentiate, we are going to have the f prime of x. It's no longer f of x, it's f prime of x. And your f prime of x equals the tangent, the gradient of the tangent. So when we differentiate here, we're going to have minus 2ax plus b. as the constant here is going to be 0 when we differentiate the constant. But I've said initially that f of x equals the gradient. And what is our gradient? We've been given our gradient here to be 3. Let me just remove these reds so that it's not very dirty. Let's say our gradient is 3. So if our gradient is 3, that means minus minus 2ax plus b is equal to the gradient, which is 3. So since we are given this and we know that we've got this point that's got minus 1 as the x value and 7 over 2 as the y value, let us go on and substitute. We use the given point x is equal to minus 1 and the gradient. I've already substituted the gradient. Let us go on and substitute the value of x. Then we'll have minus 2a into minus 1 plus b equals 3. And negative times negative is positive, so we'll have 2a plus b equals 3. Because we've got a lot of unknowns, so we are going to solve these simultaneously. We're going to have two equations. Let's use this as equation 1. Now I'm going to show you the second equation. So what are we going to do here? Let's just light this up a little bit so that we can have some space here at the bottom. We'll go back to that. Okay, now let's put this one on hold. So at the given point, at a point that we are given minus 1 and 7 over 2, so using that original equation, f of x, which is also equal to our y value, then we can say, what is f of x? F of x is f of x is minus ax squared plus bx plus 6. It's equal to the y value, which is 7 over 2. We have now equated. So f of minus 1, then we substitute minus 1 minus I beg your pardon here, minus a into minus 1 squared, you have minus b equals 7 over 2 minus 6. 7 over 2 minus 6, that's going to give us minus we're going to have 7 minus 6, so we're going to have 5 over 2. Okay, so now let us multiply or divide each term by negative. That means we're going to have positive a plus b equals 5 over 2. Then we can make this our equation 2. All right, now let's move to the left hand side so that we can try and finish this up there. We have this equation. So now let us substitute equation 2 from equation 1. Then we'll have equation 1 minus equation 2. What is equation 1? Equation 1 is 2a plus b equals 3. That's equation 1. We are subtracting. What are we subtracting? Equation 2 is a plus b equals 5 over 2. So what is 2a minus a? 2a minus a will have 1a. B minus b will have a 0. Then equal to, what is 3 minus 5 over 2? 6 minus 5 equals 1, and we have over 2. So we have a 1 over 2. Then here we have proven that a equals 1 over 2. So since we have proven this, then it means we are on the right track. So let us go on and try to prove that b is also equal to 2. So how are we going to do that? Let us substitute the value of a into any of these equations. You will need to substitute into just one equation, but I will substitute into both just to show that we can get the same answer on both. So let's say on the equation number 1, we've got 2 into 1 over 2 plus b equals 3. 2 multiplied by half is 1 plus b equals 3. Then we're going to transpose the 1 to the other side. We'll have 3 minus 1, and then b equals 2. B is equal to 2. So we have proven and we are done with that. But now let's just continue and substitute onto the other equation just to prove that we will still get the same answer on this equation number 2. Then what's a? It's half plus b equals 5 over 2. Then we'll have b equals 5 over 2. We transpose half, it will be minus half. Our lowest common denominator is 2. And then we have 5 minus 1, which is equal to 4 over 2, and 4 over 2 equals 2. So we have proven that a is equal to half and b is equal to 2 for the first question. It looked very scary, but I hope you have now realized just how simple this can be. So let us now erase everything. I hope you've been copying some notes. We've been working together. And if you have been watching this video to this far, please subscribe to this YouTube channel. Follow us on TikTok. Follow us on Facebook. On all those platforms, you just search for Get Smart with Stanford, and that is where we are. So now let us erase everything here and see if we can go on to solve the second one. Okay, the second one here says calculate the x-intercepts of f. So we're calculating the x-intercepts of that function. So on 4.2, when you're calculating the x-intercepts, we know that y is always equal to 0. So if f of x equals minus half x squared, now we say half x squared because we already know what the value of a and b, what the values of a and b are, plus 2x plus 6. All right, so we have said that we are going to equate this and make it a 0 because on x-intercept y equals 0. So minus half x squared plus 2x plus 6 equals 0. We've done just that. Okay, so what can we do here? Because if you can look at it carefully, for us to go and factorize when we have minus half there, it's not going to be very easy. So what can we do? Let us multiply each term. Multiply each term by negative 2. If we multiply each term by negative 2, we will have minus 1 over 2 times 2 x squared plus 2 times 2x plus 6 times 2 equals 2 times 0. Because what you do on the left hand side, you also do on the right hand side. Actually, I said we multiply by negative 2, not 2. Multiply by negative 2, negative 2, negative 2. I'm sorry. I'm sorry for not showing that negative, and we were going to get something which is different from what we have spoken about. We are multiplying each term by 2, by minus 2, and minus half times minus 2 equals 1. Then on this term we are left with x squared plus, now how do we have a plus? We need to make sure of that before we can continue, because we are multiplying by negative 2. If you're multiplying by a positive by a negative, you are going to have a negative. Then we'll have minus 4x. And there also, when we multiply this positive by a negative, we're going to have minus 6 times 2 is 12. Then on the other side, 2 times 0 is a 0. So now we are going to factorize. Factorizing this, you already know from your grade 10 how to factorize. We'll need to get the factors that will give us a product of minus 12 when multiplied and give us minus 4 when added. So what are those values? Those values are minus 6 and positive 2. So the x values are positive 6 or minus 2. So we are done calculating the x-intercepts, and it's just 3 marks. So that basically tells you that you're not going to do a whole lot of work. So done calculating the x-intercepts, and you've got your 3 marks in the back. Now what are they saying? They say calculate the coordinates of the turning point of f. We know that when we calculate the coordinates of the turning point, we just use this formula: x equals minus b over 2a. Now what is the value of b? The value of b is, we've calculated the value of b. We've calculated the value of b, and we found that it's positive 2, and the value of a is minus 1 over 2. You might ask yourself, why are we getting minus half there? I will show you, I will remind you just now. Then the value of x here is going to be that is 2 divided by 1, then it's going to be 2. So the reason why we are having that is because we said f of x equals minus 1 over 2 x squared plus we know the value of b also, then it's just going to be 2x plus 6. You might be confused by where did we get this negative. This is where we got the negative. If you can look on your top left now, I've just circled in red the negative. So the value of a needs to go together with that sign. Then now we've got the value of x, and since we have the value of x, we are now going to substitute it into this equation, and then wherever we find x, let me write a nice 2. This one is too ugly and it's not like me. I'm one hell of a handsome person. F of 2 equals minus 1 over 2, 2 squared plus 2 into 2 plus 6. Then what have we got here? We've got minus half times 4 plus 4 plus 6. Then what are we getting here? You can punch your calculators. Then we're getting 8. So the coordinates of the turning point, we have got at the turning point we've got 2 and 8. It's coming along looking very, very nice. Okay, it's fine. So we are done calculating the turning points. Again, if you've been watching this video to this point, please subscribe to this YouTube channel and follow Get Smart with Stanford on Facebook and on TikTok as well. Thank you so much in advance. So since we have got our x-intercepts, y-intercepts, and now we have just calculated the turning point, question 4.4 says, sketch the graph of f clearly. Indicate all intercepts in the axis and the turning point. Let us give them that. It shouldn't be difficult because we already have all the values. So what we are going to do now is just plug those values onto this Cartesian plane. Just how nice that is. So nice. So nice. So let us see. We got 1, 2, 3, 4, 5, 6. All right. We got 1, 2, 3, 4. So minus 1, minus 2, minus 3, minus 4. And we do the same going up. Let me make it a little bit longer. Open up the space up there. I'm now not getting the 3, 4, 5, 6. We know that going to the top, we've got positives, and I think we'll need to go up until 8 because there's somewhere, if I can still remember, we got an 8 somewhere. This is proving that I am not very good with my drawings, and I cannot draw up until, I cannot draw a straight line. Please forgive me. 7, 8. Okay, you will be using a ruler, so it will be much easier for you. I'm not using a ruler. I'm using some technology. I should have just copied a Cartesian plane and pasted it here. It would have been easier that way. Here we've got minus 1, minus 2, minus 3, and minus 4. We don't necessarily need to do that. You can just draw the points that you need only. It's still fine. So from the points that we know, we've got 6 and 0, we've got -2 and 0, we've got 0 and 6, and we've got a turning point of 2 and 8. 2 and 8, they meet somewhere here. Please do not, never mind my drawings. I've never been very good with drawings. I've never been very good with art, but this will show you exactly what is expected of you. Okay, but this is very nice. I never expected. And you have been instructed to clearly indicate all intercepts with the axis and the turning point. So that means you need to show all your points. Let us show them in a green color. And here at the turning point, we've got 2 and 8. Here we've got 0 and 6. Here we've got -2 and 0. And this is 6 and 0. There we go. That's all you need to do. Then you've got your, how many marks? You've got your 4 marks for drawing this. 4 beautiful marks. You've seen the Cartesian plane, so now we can go up a little bit. Okay. 4.5, they say use the graph to determine the values of x for which f of x is greater than 6. There goes the inequalities. A lot of learners are scared of inequalities. They think inequalities are very difficult, inequalities this, inequalities that. But here we are today, and we are going to prove that inequalities can be very easy. What are they saying here? They are saying f of x is greater than 6. So what is the f of x? We know that the f of x is -1/2x squared plus 2x plus 6. And they say this is greater than 6. From here, what can we do? From here, if we can multiply each term by -2 and see what we're going to get. Each term by -2, we have done this already, and here we'll be left with x squared plus 4x plus 12 is greater than 6. In this case, then we have this. So we are now going to, rather, before we do this, let us first transpose, group the like terms. So we have -1/2 x squared plus 2x is greater than 6, and when we transpose this 6 to the other side, it's -6, and 6 minus 6 is just 0. So that we can reduce the load of work, then multiply now by -2, we're going to have x squared minus 4x is greater than 0. From here, what do we do next? Because we have multiplied by a -2, then our inequality needs to change now. If you know the rules of inequality, you will know that once you multiply by or divide by negative on both sides, then the inequality will change. So on the left hand side, we've got a common factor x, and we are left with x minus 4 is less than 0, x is less than 0, or x is less than positive 4. So we can express this in this way. So our solution is between these roots. Now that we know that our solution is between these roots and we have solved what they wanted us to solve, or to determine the value of x in that inequality, we can go to 4.6. 4.6, they say sketch the graph of g of x equals minus x minus 1 on the same set of axes as f. F is the parabola that we've drawn, and this is a straight line, because if you can look at it carefully, it's in the form y equals mx plus c, and the value of the gradient there, which is m, is minus 1. Here is the minus 1, and the value of c is also minus 1. Here is the minus 1. So we are sorted. We know what this is, and we need to know how we're going to solve this one. So how do we solve this one? We find the intercepts so that we can be able to draw, and we know that when in the y-intercepts, x equals 0. So y equals minus 0 minus 1. Therefore y equals minus 1. We now have the value of y, and again x-intercepts, y equals 0. Then we have minus x minus 1 equals 0, minus x equals 1, then x equals minus 1 also. Okay, fine. So that means here we're going to have 0 and minus 1, because x is 0 and y is minus 1. And here we're going to have minus 1 and 0. And we already know that this is a straight line because of this equation. So now let us go and sketch 0 and minus 1, minus 1 and 0. 0 and minus 1 will be here, minus 1 and 0 will be here. So we draw our straight line there. It's going to be, I'm not so good with drawings. Yes. But this one, trust me, I'm going to show you flames. You want me to show you my talent? It should have gone through X, but now it decided to do something else. So let me try again. I just want to show you my talent. No, I'm not going to repeat this. You already have seen, I'm sure this one would come this way. Let me erase this. Your parabola would come all the way down, and then they would intercept somewhere there. So no, I'm not going to do it better than this. This is the best that I can do when it comes to drawings. I'm not so good. I'm not so good. So there is the graph, and now we need to show clearly the intercepts here. we have -1 and 0, and here we've got 0 and -1. Those are our intercepts. And how many marks does this one carry? It only carries 2 marks. That's because it's very simple. You're not even used to do those calculations. You can just have it, take it from your head and put it onto that graph. Now let us erase everything and see if we can do the last one, 4.7. Okay, we now are going to look at 4.7. They say write down the values of x for which f of x multiplied by g of x is less or equal to 0. What is f of x? We already know that here is our f of x. Our f of x is here. And what is our g of x? We know our g of x is here. So nice. So then we have already calculated that the x-intercepts of f of x are those ones. So our critical values here are going to be -2, -1, and 6. These are our critical values. And that is because the graph of f is 0 at -2 and 6. The graph of f is 0 there. And the graph of g is 0 at -1. Hence, we say our critical values are -2, -1, and 6. That's because these two graphs are equal to 0 at those critical points. So I believe you've now gotten what the critical point is. So now we're going to have something called a sign table. What is a sign table? That's where we're going to check what sign, be it negative or positive. Those are the signs that we're talking about. What sign are we going to get for each graph at particular intervals? Okay, here we'll have interval. Here we'll have f of x, g of x, and the product. It's a product because remember they said f of x multiplied by g of x less or equals 0. So we get a product here because we are multiplying. Okay, fine. At this interval, when x is less than minus 2, when x is less than minus 2, the graph of f is negative and the graph of g is positive. And what is the product there? Negative times positive is negative. And maybe let us divide this with a line. Doesn't have to be nice as long as you can see that it's divided. And at this interval, minus 2 less than x less than minus 1. At this interval, the graph of f is positive and the graph of g is positive. Therefore, positive times positive, the product will be positive. And at this interval, okay, let us again divide here and see if we can get a good line there. Okay, at minus 1 less than x less than 6, the graph of the graph of f here is going to be the graph of f is going to be positive, the graph of g is going to be negative, and the product therefore is negative. Okay, and when x is greater than 6, when x is greater than 6, the graph of f is negative, the graph of g is negative, and therefore the product is positive. So from this we can see that x is less or equals minus 2, or no, this one is going to be minus 1 is less or equals x less or equals to 6, because at this interval the product is negative, and this interval the product is negative, and when it's negative that means it's less or equal to 0, actually less than 0 when it's negative. So hence we've got this, hence we've got this two inequalities that suit that which were given, the values of x for which f of x times g of x will be less or equal to 0. And that brings us to the end of this grade 12 mathematics problem. And remember, questions like this test several skills at the same time. It tests your skills of differentiation, the graph interpretation, and solving inequalities. The key is to work step by step and always check your calculations. If this lesson helped you, please like the video, subscribe to the channel, and share it with other learners who might find it useful. And thank you so much for watching Get Smart with Stanford. I'll see you in the next video. Bye-bye.